Good morning, good afternoon, and good evening. Um, Today I'll be talking a little bit about MySQL Database Architectures. I'm Kenny Gryp. I'm a MySQL Product Manager at Oracle. Um, so before I get started about the database architectures I want to talk about, I want to give a little bit of a overview on the past, the present, and the future of MySQL. MySQL has been around for more than 20 years, and a lot has changed since then, of course. And in the past, and I say quote quote past, but still a lot of deployments are like this, is that setting up a replication topology is usually something that a user does by themselves. They develop their own architecture that they want. For example, they want one primary, they want two replicas, two secondaries, and they have to configure that themselves. So it used to be that you have your primary, it has all the data, you have to take a backup, either logical or physical backup. You copy the data around or load it on the secondaries. You have to basically restore from a backup, then configure replication, add a user, configure the GTIDs or the bin log file and position. So a lot of work was required to be able to set up a database architecture. And all of that work was responsible either by the end user or by tools that might exist, not made by MySQL or provided by MySQL, by other open source tools or other companies. So what MySQL did is they offered the technical parts of it and give a lot of customization to the end user to be able to set up specific architectures. So this is just an example, one primary, one or more secondaries. That's very common. There's also users that have multiple primaries asynchronously replicating towards each other. While it has a lot of limitations, and I would like you to be very careful when you set up these architectures where there's multiple primaries connected to each other, replicating between each other, like in a circular fashion, or even with two primaries asynchronously connected towards each other, so both of them are a primary and a secondary at the same time. There's a lot of, because of it being asynchronous, there's a lot of chance for conflicts that might appear. Even with auto increment settings, you can write to a table that has a unique key on a string, and then if at both databases you insert something with that key that is not unique anymore, replication will break. So it's very fragile architecture. But the point is that MySQL was, or gives you the technological pieces to set up these types of replication architectures. And yeah, it's up to the end user. Do you want it? Do you not? Do you want to take that risk? Do you know how your application behaves, that you don't have these conflicts, or that a certain architecture works? And it's up to you. Now, this flexibility is great, but it also comes at a certain cost, because you need a lot of more expertise to be able to set up these architectures, to know what best practices there are, to automate all that work. Basically, every company has to automate a part or a large part of this, or use various other tools to be able to manage architectures like this. And that's kind of the past, right? So what we have since 2016, I call that present, it's been around for about 5 years, is that we have MySQL InnoDB Cluster. And the goal of MySQL InnoDB Cluster was to try to resolve a lot of the work that is still necessary by the user. And we have an architecture where we integrate various MySQL pieces of software into a just easy to use way to set up an architecture, a common architecture. The goal is not to solve every database architecture and every variant that exists, but just what is common and what will satisfy most of the users. So it's built on MySQL Group Replication, which is the biggest piece. We also have, of course, the MySQL server, which the MySQL Group Replication is a set of multiple MySQL servers. We have MySQL Shell as the user interface and the management interface, and then Mysql Router as kind of the load balancer towards the database. So group replication is different than asynchronous replication. It has a lot of changes. It has this automatic membership management, network partition handling, split brain prevention. It has some consistency guarantees that it can provide. It can prevent stale reads. no data loss in case of a failure. So group replication solves a lot of work already. But it's not only, so group replication is one thing, it's this integration in InnoDB Cluster that is key. This shell makes it so easy to configure group application, which has like 20, 30 variables to configure, like about 5 or 10 are required. But Shell will do this. It will tell interactively in a Shell interface, like, okay, this is what you can do. These are the options. Do you want to deploy it? And yeah, it makes it easy to configure. The same with router. Configuring router is not a tedious task. There's not a lot of configuration settings. It mostly happens through the shell. You can change a running router configuration just by connecting to the database, to the group replication. So it's very nicely integrated. Router just needs to bootstrap, just connect once, and it gets its configuration from the database to be able to get up and running. Another thing we launched about 2 years ago is InnoDB CLONE plugin. Which is a way to automatically provision members. So you no longer need to take a backup, restore a backup to be able to set up a replica. You can just spin up an empty database server, then run clone, or in the case of group replication, clone is integrated. So group replication will know when a member joins, okay, I am an empty server, I need to get data, I will ask for one of the other members to donate all the data. And then clone will basically fetch all the InnoDB data or the whole database, yeah, that way we can provision a new secondary to the group. You can also use this in asynchronous replication in InnoDB Clone. It's just one single SQL command to be able to take a snapshot from a primary or a database and provision another one. It happens online. It's a physical backup. It's very fast. We've seen users that report that it's 3 times faster than other available backup tools, like physical backup tools that do backup and restore. So it just runs over MySQL protocol, so it uses the authentication security available in the MySQL protocol. So it's fully integrated in the server, easy to use. Now, that's present, so that was back in 2016, and now in 2020, January 2020, we launched MySQL InnoDB ReplicaSet, which is very similar to what we had with InnoDB Cluster, but it's kind of like a more classic approach where we use regular asynchronous replication instead of group replication. So it's the same thing with router, exactly the same way to use MySQL Router to bootstrap it and configure it. Almost the same interface for shell. There are some subtle differences. But it makes setting up a primary, secondary setup a lot easier to do. And that is something that we launched in 2020. And I'll go a little bit in depth on all of these 2 different InnoDB Cluster and InnoDB ReplicaSet. So go a bit more in depth on InnoDB Cluster. So as mentioned, it's 4 things: server, group application, shell, and router. So the goal is this single product, MySQL, built by MySQL, and it provides high availability, some scalability features, and it's just an integrated end-to-end solution, and it's very easy to use. The goals of it is it's one product. We develop these features together. It is one engineering team that does the server. We have the shell. So we have various different engineers, but we all work on this together, one roadmap to build all this feature set and to integrate it well. So we do full testing on these architectures as well. And all these components, of course, yeah, we have to align during engineering. So that's very good. That's a benefit for us and for the product, in that we have a better tested system. It's also very easy to use, and I'll show you some examples and even a demo that I recorded to show how this works and how easy to use this is. Now, to go a bit more in depth on what group replication is. So group replication is the highly available distributed MySQL database, and it provides the features as listed here. So automatic failover, network partition handling. It does conflict detection and resolution, meaning that you can have multiple primaries, not just one primary, multiple secondaries. So you can have all of them primary. They can all write transactions. The group will do the conflict detection and resolution. when a failure happens, there's no data loss, so it uses Paxos as an algorithm to replicate data, and we can guarantee that if a primary fails, or one of the primaries fails, that there's going to be no data loss. All the committed transactions, at least one other member will have it in the case of a three-group cluster. So we will have no data loss when a single primary fails. The implementation of group replication is just an implementation of a replicated database state machine. So all writes in the cluster are ordered. So even though you can have a multi-primary cluster, you can write to all of them at the same time, somehow all these writes are ordered on a cluster level. So that's what group replication takes plugin takes care of. So it's using XCOM underneath, so that's the Paxos implementation that we're using. So it's not pure Paxos, it's kind of a variant on Paxos. Yeah. Some of the neater features that we have is the configurable consistency guarantees. So by default, so replicating is still asynchronous. This is not a fully synchronous replication method. It is, replication is asynchronous, meaning that if I write something on the primary and I commit that transaction, if that commit succeeded and I immediately read this data that I wrote on a secondary, there's no guarantee that that data will already be visible. So it is asynchronous. The replication by itself happens through Paxos, and what happens is that in Paxos the majority of the members, so in the case of 3 members, 2 of them have to reply, so the primary itself and one of the secondaries, and then it can have a transaction to succeed and to go ahead. So basically you establish order, you establish that majority has received it, so when that failure happens, that the other members can recover. Now, so being it asynchronous, it is very different than classic asynchronous replication in MySQL, and even semi-sync, which is a plugin on top of asynchronous replication. The benefits that we have in group replication is that you can just set on a certain connection or on a database server itself or on the cluster which consistency level you want. So the default is eventual consistency, and meaning that there is possibility that you see some stale data on a replica, on a secondary. But you can set some setting group replication consistency to before or after. So there's a couple of different types of consistency levels that we have. I think we have about 4 in total, yeah. You can say I want before consistency. So on that secondary that might not have applied all the transactions, when you set the group consistency level to before, and when you start a read transaction, you do a select. With this before mode, it will guarantee that before that transaction starts, that everything is applied, the whole queue is applied, and it will read that data that was committed on the primary before that transaction started. So that's a way to avoid stale reads. It does add latency to that read transaction, of course, if needed. Although that it's not always a round trip between the hosts that is added. It kind of depends on the workload that is running and so on. There's another consistency level after, meaning that when I do a write transaction on the primary, if I set my group consistency level to after, when I commit that transaction will the commit will only succeed after all the other members have received the transaction, prepared, and committed the transaction. So that's a way to guarantee that, okay, this transaction will be immediately read by all the other transactions on the whole cluster. So this also means there's some added latency during the write transaction. But the benefit is that when you read on a secondary, there's no added latency on the secondary, and it will see no stale data, because the after part on the writing transaction will guarantee that that every read in the whole cluster will not see any stale data at that point. So you can set this on a global level, on a read level. So these are 2 of the modes. There's actually 2 more. So we have before and after, and then we have before on primary failover. These are some variances. So check our website, and we have some blogs about it on MySQLHighAvailability.com. So this is an 8.0 feature. So group replication by itself and InnoDB Cluster has been available since MySQL 5.7. Although I do recommend to use MySQL 8, There's a lot of changes in MySQL 8 and Group Replication in MySQL 8 that really make it worthwhile and make it a lot easier to use and a lot more features as well. Another benefit of Group Replication is that it's not a whole new piece of technology. It's built on top of the MySQL replication framework as used by point-in-time recovery. Basically, point-in-time recovery requires binary logs. The Group Replication leverages this, uses this binary logs, relay logs, GTIDs, global transaction IDs. It's using all this, so it's not yet another implementation of some replication method. And of course, we do support at Oracle all platforms, so Linux, Windows are supported by us. So what are the use cases? Just to summarize a little bit. So no data loss, so recovery point objective of 0, it can be reached in the event of a failure of a member. So with 3 members, you need, is recommended, 3 or 5 members, or at least an uneven amount of members. Because we have this quorum-based, so basically when we have 3 members, when one fails, 2 others will elect a new primary and will continue. If you only have 2 members, when the primary dies, the secondary cannot establish a majority, cannot establish quorum to be able to know, okay, I can become a primary, because it only has 50% of the votes. And you need more than 50% to be able to establish a new primary. So that's why 3 or 5 members are generally recommended in most standardized setups. So we have this automatic failover. So when a primary goes away or gets network partitioned, a new primary will automatically be elected. There's no monitoring tool, no external monitoring tools, no external hosts making any decisions, because often these tools can make the wrong decisions. It's fully integrated in Group Replication, and network partitions are automatically handled. So if a server is offline due to network issues, when the network comes back, it just joins back into the group. It will also, if it's gone for too long, the primary or the majority group where the primary is located might expel another member if it's gone for too long, but that member can always rejoin. So all easy to use, automatically doing this failover. So of course the role changes between the database servers, and each database has their own way to access it, to its own IP address, for example. So that's why we have this router on top, which continues to monitor and knows, okay, where is the primary located, and therefore can follow the primary and redirect the connections over there. So that's a good plus. That's the good thing about this integration, of course. So read scale out as possible. Of course, you can add and remove members as you need. We have these consistency levels that I mentioned about. One thing that also is different when we compare to regular replication, the asynchronous replication, is that there's flow control settings. So you can control replication lag. So it's integrated in Group Replication. So if a secondary is falling too much behind, it cannot catch up with applying write transactions due to a select workload, or maybe it's slower due to some disk I/O issues or whatnot. Then the primary member will notice, okay, we have a member that is lagging behind, it has a lot of transactions to apply, the queue is growing, and then the flow control settings will determine what it should do. Okay, there is some delay, so flow control might kick in, and it might, for example, delay some transaction, add a little bit of latency. So when we commit the transaction, instead of normally taking 0.2 milliseconds, it might take 0.5 milliseconds. So flow control will add a little bit of latency to make sure that, of course, we don't stop the whole world and stop all write transactions. So we don't ever do that, but to slow it down gently so that the secondaries can catch up. So therefore, it is also important that every member in the group has to have equal resources, or you might run into these issues where flow control starts. So don't make your secondaries have less CPU, less disk bandwidth or throughput, or higher latency to disk. So that can have an effect, of course. And of course, this active-active that I mentioned, so you can write to multiple members at the same time. Writes are ordered within the whole group, so we can guarantee consistency, and we have this conflict detection and resolution built in. and it's a kind of an optimistic locking that happens. So basically the first committer will win. The first one to commit will establish order within the group and will continue. Any transaction that is trying to update similar rows than that committed transaction within the group will have to be rolled back, and group replication will roll it back. So the application will always get an OK back or a rollback on a transaction, during a transaction, or at commit of a transaction. There are some cases, of course, where that workload might conflict a lot, so therefore it doesn't apply to every use case, but often it just works fine. There's some other limitations to this as well related to foreign keys. The default that we have is single primary mode, which is one primary, multiple secondaries. So it's not a scale-out system. Every database server in the group has the full data set and has to apply every write transaction. So that is not any write scalability cannot be achieved. Now to talk a bit about MySQL Router. So Router provides this access from your application to the backend database server. So right now it does some load balancing. There's TLS offload that we recently released, so you can do TLS at the MySQL Router level and configure it there, so you can have different certificates. And also, if the router is located closer to the application server, the TLS handshake to set up this connection can improve latency. And Router can then also use encrypted connections to group application, to the database service as well, of course. So it does load balancing, this TLS offload. It understands so both group replication and MySQL replication as part of InnoDB Cluster or InnoDB ReplicaSet. So at this moment, this is a TCP level load balancer, so it gives you a port for primary traffic and non-primary traffic. So primary traffic goes to the primary server, so if there's a single primary mode, there is only one. Non-primary meaning the secondaries, so the secondaries read traffic, basically. So you do have to change your application to say read and write, where are they going to be located. But you can use this group level consistency settings to say this non-primary traffic should not read any stale reads, for example. It's stateless by design. It's a very small application. We do recommend it to install it as part of the application server. So you can have many routers, hundreds of routers connected to one group application is possible. We have several customers that use this. That's not a problem. We also have we have the MySQL Classic protocol, so on port 3306. We also have the X plugin protocol for a couple of years already. And there we did add some features to group replication and router, where instead of router performing health checks to group replication every half a second, for example, is there a new primary? Is there a new primary? Is there a new primary? It can subscribe using the X plugin and say, okay, let me know when the topology changes. And then group replication sends a push to all the routers that are online and active to say, okay, the group view changed, we have a new primary. So the routers don't have to poll us frequently the status of the group. So this is some of the improvements that we did to make sure that router is very lightweight. You can have hundreds of routers connected to one group. It all works good. You can also install router as a separate layer, but then you need a way to kind of load balance from the application, either using a DNS. DNSSRV is something we added to our clients in last year as well. So you can use DNSSRV to find where the routers are, or some virtual IP that moves around, people IP, things like that. And then we have MySQL Shell, which is this interface. So we have the MySQL Classic client, the MySQL client, and then we have the MySQL Shell client. And it's very different than the current, the original MySQL client. It supports both the regular MySQL protocol and the X protocol. And when you first connect, the default is JavaScript mode. So you can write JavaScript, Python, you can write some modules, some plugins for yourself, and it's scriptable. It's easy to use, and you can also move to SQL mode, of course, to run SQL statements. But what is good is that you can basically run JavaScript or Python commands to set up this group replication, InnoDB cluster, and so on. So Shell does more than InnoDB Cluster or connect to a database. It also has tools to dump data, import data. So we have a logical dump and a logical load that is very fast, has a lot of features. We also have tools like importing and exporting tables, CSV tables fast. So various tools exist inside Shell. There's a way to report, like to generate reports, things like that. There's also plugins. I think Lefred made a lot of extensions to Shell where he's doing a lot of troubleshooting tasks a lot of people have to do, or to make MySQL, operating MySQL a lot easier. So he wrote a lot of like plugins for within Shell. So he often blogs about it on lefred.be. So here's an example on how you set up MySQL InnoDB Cluster. It's really easy. So it's basically you connect to the database MySQL 1, and then so we're connected using JavaScript mode here, and we say cluster object, okay, dba.create cluster with the name cluster. So it generates a cluster, and the primary that will be is MySQL 1 because that's where we were connected to. Then we can say I want to configure another server. So MySQL 2 I want to add to the group, but first I want to configure it. In MySQL 8, you can configure configuration variables and restart the database all through an SQL interface. So you don't have to edit my.cnf files. You just say configure instance. It will tell you this, this, and this. You need to change. Do you want me to apply it? Restart the database? Yes, please do. And it does it. And then the other thing is after it's configured. So there are some settings that are required to be configured that are needed for group application to operate properly. And so therefore we have this configure instance step. And then to add a server to the cluster is just you have that cluster object and you say cluster.add instance MySQL 2. And it will do everything from provisioning if needed. And it will ask you, do you want to provision using binary logs or you want to do clone? What do you want to do? And it will add the users, configure everything, and by the time that command is done, the whole you'll have a two-member group. And then to use router, it's quite easy. So you do MySQL router and you say bootstrap. And you say where to connect to. So basically you connect it to MySQL 1 or MySQL 2, doesn't matter. It can be a primary, it can be a secondary. What it will do is will read the group membership, the metadata that is located on the server that Shell writes, and then knows, okay, this is what I need to do. There's various features like tagging available to hide servers. It knows all this metadata and it assembles the data, stores it, and when router started, it will continue to refresh that metadata. We also have, for example, a REST API on MySQL Router to check status, and the authentication, for example, can be offloaded to the group. So instead of having to manage authentication files on every router server, that can be stored on the database. And then you can do through Shell and say, I want to configure the user accounts like this and that. But therefore, for doing that, you still need to use the lefred.be, his Shell plugins to configure router users at this moment. So after you have a three-node cluster, for example, you do cluster.status, and it will basically show you the status of the group. And you get a JSON object, so it always returns a JSON object. So we have cluster, which is cluster. The primary is MySQL 1. It's with SSL. It's all good. There's online. There's one failure that it can sustain. And then it shows you the topology. So we have MySQL 1 in read-write. We have MySQL 2 in read-only, and MySQL 3 in read-only. So read-write, read-only, it's all automatically configured by the group. So the primaries get read-write. The secondaries become read-only. If one of the servers is missing, it will give you that information. It will say this one is missing. It might not be part of the group anymore, but it's still in the metadata. Shell still expects that server to be there. So it will try to connect, see what happens. It can fix it as well. So there's commands to scan, to rebuild the cluster, restart the cluster if everything went out. So everything is automated within Shell. So about MySQL InnoDB Cluster, so it became GA first in 2016, and it first saw the light of day in 2014. So it's been around for about 6.5 years, and a lot of the features that we added, and here we go up to 8.0.18. So basically up until beginning last year, A lot of features were added in 8 to make group replication a lot easier, a lot better to operate, a lot of functions. Things like clone, being able to switch primaries online, auto rejoin, several settings that become more configurable in 8.0. We also added various other features, and maybe one feature that I might show here is one of the things that we added to asynchronous replication is that when you have a group replication or InnoDB cluster, it doesn't matter, and you have a replica attached to that group, and you want to have it asynchronously replicating, you up until 8.0.24, or no, 23 actually, we added, 23, just double checking, which was at least beginning of this year. You had to manually configure, okay, either say on the replica, I want to connect to the group, to this primary. You either had to connect through a router or manually say where is the primary. So if the primary switched or a server was added and it became the primary, you had to change all your replicas that were attached to it. So with this feature, we actually built in a way to automatically do this. So when we have this replica, which is asynchronously replicating from server 1, which is the primary in the group, when that dies, I'll show you just not how to configure, but the diagram. When S1 dies and S2 becomes the primary, replication will automatically be reconfigured and replicating from the new primary. So we built in some monitoring and an ability to specify a set of servers in a single asynchronous replication configuration. So it makes it a lot easier to do all this. You don't have to do anything to your replicas. It will automatically follow. You can configure either follow secondaries or follow primaries. So you can kind of set the weight for each role, each type of role. You can also customize. It doesn't have to be group replication. We made it possible that you can add, just if you have other tools or another architecture, that you can manually say, okay, this is the list of servers, this is the priority. If you cannot find server 1, go to server 2, and so on. So you can build your own automation on top of that. But it was specifically built for group application, of course. So that's available in 8.0.23. This is one of the examples that we're trying to make replication easier to use, keeping it as a technology very customizable for a lot of our users, of course, but also making sure it starts to integrate better and make it easier for our users. Because these days, users have to kind of manage a lot more different types of databases, or they just spend a lot of time on automation, which will reduce all the work needed there. So the adoption has been really great. We have a lot of customers and a lot of community that using MySQL InnoDB Cluster. And the reasons I think is, okay, we have group replication, which is really good in making this easy and having this no data loss in case of a failure, automatic failover, and so on. But also the integration that just in 4 or 5 commands, you have a cluster up and running, and you have a router running, and all this stuff is just basically, you don't need to be a MySQL expert. You don't have to hire a MySQL consulting company or find the experts to be able to set up a really good architecture. You don't have to guess, you don't have to Google. There's a lot of misinformation about MySQL available online, either due to legacy or people not aware of features that were made in 5.6, 5.7, 8.0, and so on. So it's a lot of wrong information can be found on the internet, unfortunately. A lot of good information as well. But this is very important to make it a standardized set of architectures. As example, InnoDB Cluster makes it easier to use, easier for us to support, and to build on top of that. And this is what our customers are asking for, our users are asking for, and of course that's what we provide. Now, as extra to this is we have InnoDB ReplicaSet, and it's very much similar but slightly different. Both have their pros and cons, but because of this ease of use, we've seen that, okay, this is what users want. They don't want to set up traditional replication anymore, because in MySQL Shell and MySQL InnoDB Cluster, it all happens automatically. But sometimes we have users that do not fit group replication very well, either because of they have a network that is not reliable. Group replication does require a reliable network, and maybe that's not possible to be provided. We have several customers like that. We also have customers that, okay, there are certain limitations in group applications, Like, for example, there used to be this limitation where a primary key was required in group replication. Every table had to have a primary key. While it's even not optimal with asynchronous replication, it is still recommended, but group replication denies any rights to a table without primary key. Now, we have resolved this in 8023, where it is possible to add an invisible column as a primary key, so no changes to the application, but underneath, with just one alter table statement, you can add a hidden primary key, which is not like this generated InnoDB cluster index, but is just an auto increment big-int, or whatever you want it to be. But the auto increment is basically needed, or a UID would work as well. And it's hidden, so if you do select star, it doesn't show it. You don't need to specify the column with an insert statement, so completely transparent to the application and very easy to kind of migrate into. Now, this is just some of the limitations that we're lifting as we go release MySQL versions, of course. But there's still reasons, okay, maybe asynchronous replication is what they require. I'll show you a little bit later what kind of the differences are there and when to choose what. And therefore, we built InnoDB Replica Set is to basically have the same way of using Shell to add and remove members, to have this router routing automatically, because without Replica Set before that, you had to manually configure every router to say where are the members located, where's the primary, and so on. And to leverage clone, of course, integrate InnoDB's clone to provision members. And basically, in the past, you had to restore a backup, and when you want to set up asynchronous replication, now you don't. Within the replica set, it automatically does clone when needed to provision members. You used to have to configure users, permissions, configure the replication with the GTID or binlog file and position. Shell will take all of that responsibility for you, and it will do all that for you. You manually had to manage router. Now you don't have to do that anymore. Same thing, bootstrap, run, done. Same as InnoDB Cluster. There's basically no difference in configuration between router connected to InnoDB Cluster or InnoDB ReplicaSet. You also don't need to rely on other tools or a lot of manual steps to make a switchover or a failover. So InnoDB ReplicaSet does not provide automatic failover, and we have some reasons for that. And reasons is that if we would have some external tool making decisions on who should be the primary, it can get quite complex. There are tools available that do this, but they have to go a long way to guarantee no data loss. Split brain is often cannot be guaranteed with asynchronous replication. Either some semi-synchronous plugin has to be enabled to make it work, but that comes with a lot of kind of impacts as well, a lot of downsides to this as well. So what we wanted to provide is the same way to configure MySQL replication as InnoDB Cluster, not need this automatic failover. A lot of users we've seen do not require automatic failover all the time. They prefer to manually do it because either it doesn't come at a great cost to have some downtime, they can have this lower availability, but also it's a more architecture that if network fails, that it's not causing primaries to shift automatically. So it does have its benefit there. But what we needed to provide is a way to easily do a switchover or a failover when it's needed. So we do distinguish between switchover and failover. Switchover is when it's planned, when all members are, the group is, or the replica set is healthy. You do a switchover, so you promote a new primary and the other ones become a secondary. And with the failover, it's when the primary is gone and then you need to force another one to become primary. Split break cannot be prevented in all cases, especially if you have no access to the primary, of course. So there's no split brain prevention like is available in group replication, which is built into the replication, which is not the case here. So you don't have to kind of build your own monitoring tools or connect to every database to see the health of replication architecture. You can just do status and it will connect to all servers, check what the replication lag is, give some data about that. So easy to done. You get a JSON object back. Easier to use because Shell configures all this. The replica set configures the server, the router, the replication, using best practices that are working well. It prevents all these mistakes that can happen in setting it up. Over the course of years as a consultant, I've seen many users deploy replication in different ways, have their own settings that they take from legacy versions where they're still hard coding some configuration variables, even though they've long become unnecessary and even bad for newer versions of MySQL. So Shell will take care of all of that for you. And of course, every setup in MySQL Replication before InnoDB ReplicaSet was customized anyway. So it takes some time to get to know what it is, what is the architecture, to guarantee that it works in all possible ways. And this is a very standardized solution, easy to explain. It's supported, QA'd as an entire solution by Oracle, of course. And this is easy to use even for MySQL beginners. And I have seen a lot of like customized, over-engineered architectures, even though the business did not require it, just to do certain kind of failover. They would have more management nodes and clusters to monitor the database or replication, to promote a new primary, than actual database architectures, which is one primary, two secondaries, for example, or one secondary. So no, this is very easy, basically entry level in a way, to make it easy to use, easy to set up. So what are the requirements of InnoDB ReplicaSet? And that is MySQL 8. That is the biggest requirement, because one of the main features is restart, InnoDB clone, set persist to set MySQL variable configuration settings on and over MySQL connections. So basically not needing to connect to the server itself. Using SSH, you never need to access to a terminal, manually edit configuration files. We want to like remove all the need for that. Oh, one like nice feature in MySQL 8, and Shell does not yet leverage it enough, but is that you have the access to the error log at this moment. So you can just go to performance schema, error log, it's a table. You can see the error log, so no need to check the error log by logging in. You can just check it over MySQL connection. Makes it easy to collect error logs from multiple servers, compare them, and so on. So the limitations, as mentioned, manual failover. We don't have a multi-tiered replication architecture, meaning you have a primary, a secondary, and then the secondary has another secondary underneath. So multiple levels, a multi-tiered architecture is not supported in this setup. Not sure if we actually ever will. This is not meant as a architecture that is meant for very large deployments. So that's where this solution aims to solve this particular problem of ease of use, easy to set up architecture, and that does not require multiple replication levels. Not multi-primary as well as, of course, because we cannot guarantee data consistency, so we will not make a solution that cannot guarantee data consistency. It would really be difficult to explain. Like you can do multi-primary setup with asynchronous replication, operated and supported by Oracle, even though it doesn't guarantee any data consistency. So this is not something that we want to do. So this is not supported. We will prevent this as much as possible, because we see a lot of pain in that users are misusing this, of course. So we want to be careful in a solution that we provide like this. So here's a little demo that I can show. So we're connecting to MySQL using MySQL Shell. So here's the MySQL Shell. We're connected. We have connected as root to localhost port 3301. In this case, we're demoing Replica Set. So we do create Replica Set. So DBA create Replica Set or create cluster. Same command basically. So we can check the status. The status is that there is one primary in read write, and that is it. But yeah, of course, it's just a single machine. So let's say we add another host here, localhost port 3302, and it says, okay, but there's no data, the GTID set is empty. What do you want to do? Do you want to clone? That's what it recommends. So here it goes, we chose clone, and it's performing the clone. It's a straight server to server communication to fetch all the data, and it restarts, comes back up, and before you know it, you have a primary and a secondary, so read write and read only. So you can add another instance, and then that's 3303, quite easy. And you'll have three three members, basically one primary, two secondaries. So we use the same terminology as with the group replication, primary, secondary, to determine what the role of a server is. In the context of a replication setting, so basically a primary and a secondary is replicating between each other, the setting of replication is called replicating from the source to a replica. So the commands that we use is change replication source, or show replica status, start replica, and so on. But in the context of a server role, we say primary, secondary. So yeah, we have a three servers now, and we can change the primary by just setting the primary instance, and done. So we're making 3302 the primary, it was 3301, and that's done. That's basically a switchover. So we can check the status, and you'll see that this one is read-write now, 3302 is read-write. So if I stop a server, like basically create a crash, you can see if we do cluster status, I need to refetch the object because it was connected to 3301. You will see that replication is stopped. It will have an error here, error connecting. 3302 cannot connect. It was the primary. 3301 has the same problem, of course. So you can fix this by doing a failover, which is just one single command, force primary instance, and then you say, I want 3301 to be the primary. So it's going to check, make sure that 3302, who was the primary, is not available, of course, and then change the whole setting. And it will invalidate the host that was gone. Now that host can still be running network partition and still accepting writes. So there's no split brain prevention here, but it is invalidated. And when 3302 comes back, it basically will show, Shell will show, oh, this host was invalidated, that's a problem. So look, I started 3302, we're waiting a little bit until it comes back. So if we check status, 3302 now says, oh, it was invalidated and must be removed from the replica set. So you have to remove it with remove instance. Also, it says this is in read-write mode right now, danger, danger. You might still have applications running on it, so be careful there. So it will report that. So if there is a error in transactions or a split brain, it will say, hey, there's this many transactions that are executed there that the other members don't have. This is a problem. Please go fix that. So we provide the tools to identify all this status of the group and to fix it if possible, of course. So you can rejoin the instance too. In this case, there was no transactions that were already executed, no split brain, so rejoining is easy. If there are transactions, then you'll have to fix this first to figure out what are these GTID events, apply them, fix it. This all depends on the application and the data that was changed, of course. So now we're showing router. So router, we're using user shell, so we're using the OS user MySQL router, we're bootstrapping to port 3201. Done, it bootstrapped, just connect username, password. It generates the users, it doesn't use the root user, of course. Creates a user with limited privileges, and then when we start router, it will figure out what is the topology look like. So if I switch primaries, for example, so we're tailing the log file of router as well, you can see that it immediately shows that, oh, I noticed that there's a new member read-write, so it changes and switches the connections of all the applications to the new read-write. So here, I show it again. Okay, that was the demo. So very easy to use. So quickly, I'm kind of low on time, but what are the commands that we have? So InnoDB Cluster, InnoDB ReplicaSet, it's very much similar. Create cluster, create replica set. Configuring an instance is configure instance or configure replica set instance. There's different configuration variable requirements for a replica set than is for InnoDB Cluster. Adding a server to the cluster, same command. Router, the same. Status, the same, and so on. So the demo, if you have this, looking at the slides and you want to see the slides, you can just see it on this blog post. So now talking a little bit about when to choose what, of course. And what is important is that we talk about recovery time objective, meaning how fast should the service recover from a specific failure. And recovery point objective is how much data can we lose when there's a failure happening. Now, RTO and RPO are not just, okay, I want recover from 1 hour. It needs to be in the context of some type of failure. And we have several types of failures. We have high availability, meaning some network partition or a single server failing. Disaster recovery is when a full region or a data center fails. Or a human error where somebody drops the database, like the little Bobby tables, drops the table. And then you need to recover from a backup. So the RTO and RPO are different, or are usually different, between these types of failures. And the question is, how much is it? You can determine in time, so a few seconds, minutes. I need to recover within 4 hours if it's a human error. If it's high availability, I need to recover within 10 minutes. Disaster recovery, I'm okay in 2 hours, for example. You can also explain it in transactions, in recovery point objective. I want to lose 10 transaction maximum, and so on. But what does your business need, right? So if we think about RTO, RPO, and especially InnoDB Cluster and Replica Set, we talk about a single region in most cases, not all cases, as you can see, as you'll see. So if your RTO, your recovery time can be hours, and you can lose minutes of data, you can just take a backup and save the binary logs to do point-in-time recovery. You can do that, and then you'll meet this. So you don't need replication if these are your requirements. If you want the less RPO, you can also remote binary fetch the binary logs using MySQL bin log, for example, to do the point-in-time recovery. So when the server dies entirely, you have basically all the data, maybe a couple of milliseconds lost that you might not get in most circumstances. But okay, these are the less interesting ones, of course, but they are still very valid, and some users might choose this, of course. If the recovery time needs to be minutes or more, it kind of depends on how fast you are as an operator, or if you want to put some automation on top of this. But the biggest one is you can lose some data. If you can lose some data, then MySQL InnoDB ReplicaSet might be a good choice for you. If you cannot lose any data, then you cannot use MySQL InnoDB ReplicaSet. You have to use MySQL InnoDB Cluster because of Group Replication, of course. The recovery time of Group Replication, the default is 5 seconds. After 5 seconds of a host being down, it will elect a new primary. So you can basically say within seconds, within 10 seconds, a new primary will be elected in most cases. So no data loss in case of a primary failing. So this is in the context of a single region. So there we're talking about high availability here, the type of failure. We don't cover human error in this slide. This is just recovering from a backup. So this is another topic to talk about. So you recover from backup, do point-in-time recovery if not needed, and so on. But now if we go to multiple regions, we're talking about disaster recovery, okay? And this is a little bit more tricky and a little bit more difficult. So if a region fails, my RTO has to be minutes, meaning that I have to be available within minutes. Again, this depends on your operations team. How quickly can you make a decision? So minutes could be 10, 20 minutes as well. And if you are okay with losing some data, then you can do MySQL InnoDB Cluster and attach a asynchronous replica to it. So remember early in the presentation I was talking about this automatic failover, of the connection, the replication connection. This is an example. This helps with this, of course. Then the replica automatically knows where the primary is located. So the good thing is that there's no impact in write transactions in terms of there's no added latency because it's asynchronous between the different regions. So that's good. So there's no noticeable impact on latency. But you can lose some of the data because it is asynchronous, of course. If you really cannot lose any data when a failure happens, then there are some choices. It's running Group Replication or InnoDB Cluster in multiple regions. You need a very stable network, preferably lower latency, but it can work on a bit higher latency networks. It requires one round trip to basically send the transaction to each server. So it's not like 2 or 3 round trips to be able to commit a transaction. So the overhead is only 1 round trip, and it is at commit of a transaction. So during a transaction, there is no overhead at all. So there's no locking information shared. It is only at commit that the communication with the other members happens. Selects are not impacted as well, of course, except when you set those consistency levels. Now, what's the difference here? The first diagram on top is you have two members in one region and another member in another region. You need to use group consistency level after, which guarantees that every transaction will be committed to the third node on the other region. Without it, there is no, it's Paxos, it needs a majority. So the majority can be established within a region. So there is still the possibility to lose data. With consistency level after, it will commit it to the other host on the other region, and then you have no data loss. Now, there are some quirks about it. You have this expel timeout, so when the network goes down, the expel timeout might kick out the third member, so you would have to configure kind of expel timeout to be higher. So it is quite tricky, not really like the most subtle solution. And usually your failover time will be a lot higher because of this expel timeout that you have to configure. But we do have multiple customers having multiple data centers, more than 2, and they run MySQL Group Replication across 3 different regions. And then you don't have to set any consistency level, then it does work, automatic failover. Oh, what I forgot to mention on the first one, there is no automatic failover to the secondary region because the second region with the one host always is a minority. So you have to basically fence the primary yourself, the 2 members, and then promote the secondary one. So it is kind of tricky, and therefore it's kind of less recommended. The best way is to have three regions, of course, 3 data centers. So which solution is best for my business? So there are some other things. If you need fully consistent reads on every host, then you need to use InnoDB Cluster. Multi-primary, InnoDB Cluster, of course, is what you would require. So to summarize, here's a summary. So single region based on the recommendations. It's the same as what I mentioned in my previous slide, just a little summary that would be required. So yeah, if there's any time left, there's some questions, just post them in the chat. I'll try to answer them on the chat or in the Q&A on the event website. Thank you very much for listening. Thank you. Bye.